Next speaker is actually Dr. Marissa Morales-Rodriguez, a project manager in the field of research and development of cyber-physical sensors at ORNL. Like me, she's also a graduate of the University of Tennessee, right down the road in Knoxville. So please welcome Dr. Marissa Morales-Rodriguez.
Thank you. Well, thank you, Heather. And wasn't that a fantastic presentation by Dr. Smith? Just give it another round of applause. I don't know if it's here or not. It was great. So I'll try not to bore you all with my story. I think that he put my slides to shame. But today, I wanted to share with you who I am and what I do and how I got there, right? And so I will take you to a journey from when I went to school and I was with you, like you guys, and until today, and what I do, and what kind of things I had to go through, and that kind of things. And in the beginning, we were discussing, Heather was discussing what is a geek and how did it look like? Well, it looks like me, and it looks like her, and it doesn't have really a type. If you're into science, you don't need to be looking certain way or behaving certain way or be certain way. It's just something that you like, right? And that's me. That's kind of, what I bring this up. Okay, so let's just start. This is an outline of the presentation. So I will be talking about who I am and my trajectory, which includes education and some of the things I went through, the challenges, what I'm doing right now, and some of the lessons I've learned over the years. So I am from Puerto Rico, and do you know where that is? Now it's in the news, right, because of all of the struggles with the hurricane. So Puerto Rico is a U.S. territory, and it's located it's an island located in the Caribbean. It has about 3.4 million people, a little less now after the hurricane. A lot of people have left. And it's 100 miles long, 35 miles wide. And I was born in San Juan, the capital city, which you see a picture there in the left below, lower corner. And there's beautiful, beautiful beaches all around the island. And I was born and raised in a town called Toa Alta, which is 30 minutes west from San Juan. And that's where I went to school there. And I went to school in Toa Alta, which I went to the public system. And it was really good experience. But looking back, there was a lot of struggle, limited resources. Sometimes we have to photocopy a book because there's just one book for the entire class, and there was no computers. So science was not something that was visible to me growing up, right? So how in the world someone that has not that opportunity, right, to be connected with the science world end up being a scientist? Well, I asked myself that question a lot. And so looking back and putting this presentation together, I realized that it was always very natural in me having a curiosity about how things work, how things are made of, how do they connect with each other. And that kind of things were something that defined whether I was going to pursue a science career or whether I was going to pursue something else. When I graduated high school, we were encouraged to pursue a 2-year degree, which is not a bad thing if that's what you want to do. But I wanted to do more. And I remember having this conversation with the counselor at school, and he suggested for me not to pursue chemical engineer, which is what I wanted to do. And I wanted to do chemical engineer because at that time I had a cousin who was finishing this degree, and I was so curious about what do they do. So I have a conversation with her, and she told me what she was studying, the classes she was taking, and I was like, yeah, I want to do that. But when I go to school talking about applications of the university, I was not really encouraged to pursue that. And I said, you know what? I'm not going to listen to this person. I'm just going to anyway apply, and I did apply to the Natural Sciences program at the University of Puerto Rico, where I finished a 2-year degree, and then I had to transfer to another campus to pursue either chemistry, biology, physics, or math. And how do you choose? I didn't always knew what I wanted to do. So I said, well, what do I like? And then my mom reminded me, you've always been good at science, so you're going to pursue that. And then she said, and do you remember when you were a very small kid, probably 5 years old, 6 years old, she said, you like to mix stuff. Like I would take water and oil and put it together, shake it until the thing was not mixed, which it never did, of course. But then I put it in the freezer, see what happens. Next day I pull it up, and then, or I just took some mixtures of spices and condiments and stuff like that and put it underground. And you can tell my mom was really happy with that. To have the refrigerator full of little jars with different stuff. So I said, you know what, I'm going to study chemistry. And at the time I was fascinated with cosmetics, of course. And then I said, maybe I can be a cosmetic chemist, I can work at L'Oreal. And that was a goal, that was a life goal when I was 23. And it never happened, okay? So, but I did get my chemistry degree, and I got a bachelor degree and a master degree in physical chemistry. So it was always a lot of work, and how I got, I forgot to tell you about this. So let's go one back. Okay, when I was in chemistry, I didn't necessarily, when I was doing the transfer between one campus to the other, in Puerto Rico, there are limited space for each program, right, that they can accommodate people, such a small island. So they said, sorry, but we're not going to admit you in the chemistry department because, you know, the spaces are full and maybe you don't have the best grades, which I have a 3.3, that's not a bad thing. So I said, well, what do I do now? All my goals and dreams are crushed. And then my mother, she's always come back and said, well, maybe there's another program you can join in and then you transfer again. And I said, well, then let me think about that. So what do you need to be a cosmetic chemist? So I did my research, and one of the requirements is that it would be beneficial if you can know French. And I said, then I'm gonna go through the French department, and so I did. So I transferred from the natural sciences department from one campus to the French department on the Mayagüez campus, all the way to the west side of the island. And then the minute I put my feet on the campus, I went to the chemistry department and said, hey, look, this makes no sense. So you need to transfer me like right away. And they did, okay? So then I finished all my courses there, getting a master's degree. I did 2 fellowships and internships, 1 internships, 1 fellowship. Also, they were sponsored by ORAU. I did not know that until I did my research this morning. And to make sure about that, the Mickey Leland Energy Fellowship and the faculty and student teams DOE Fellowship, because I strongly encourage you to pursue internships while you are pursuing your undergraduate degree. And this is because it will give you a good view of what the real life is if in a science field, right? So those were very, very good experiences. And the faculty and student internship landed me a job at ORNL. So I did that in 2009. I moved to Tennessee. Those are 1,600 miles away from Puerto Rico. So when I was making that decision, my father was not very happy with that. Imagine how many parents are here today. There are any parents? You are. Imagine sending your only daughter 1,600 miles away where you don't know where Tennessee is or what kind of people are there. You know, you don't even speak the language. So he was like, well, I don't know about that. I said, don't worry. He said, well, I don't have any money to send you there. I'm like, don't worry, it'll work out. And it did work out pretty well. So I was at ORAU Postmasters until 2011 at ORNL, and an R&D staff member now until today. So during work time at ORNL, I also completed my PhD. I started in 2015, that was in January, where I joined the Bredesen Center. Anyone you familiar with the Bredesen Center? It's a program at the University of Tennessee, and it's an interdisciplinary research and graduate education. So they combine science, energy sciences, and they combine policy and entrepreneurship. So I was drawn to the program because my goal in life at some point would be to have my own company. not to do more cosmetics, because I don't want to be, L'Oreal rival or anything like that, but to have a technology company. So I was drawn into the program, and it was a fantastic experience. And I encourage any one of you to take a look at it. And if that's something that interests you, don't hesitate to shoot an email. They're really responsive, and they will be happy to talk to you about the program. And I finished my PhD in 2017, and I have a degree in energy science and engineering. So what does this scientist do at ORNL? So I am a principal investigator and a project manager in projects related to cyber physical security and smart grid. And what does that mean? Does anyone knows what a smart grid is? So the smart grid is the electrical system that deliver energy to your house, or electricity to your house. And we want to put many sensors and technology to make this, the grid, innovative, self-healing in case of there's an outage, to have rapid response of what's happening, and then try to fix things as soon as possible so the clients, the customers, don't spend a long time without the service. And so I am a staff at ORNL at the Electrical and Electronic System Research Division, and I work at the Sensors and Embedded Systems Group. And here you have some pictures, some of the things I've done in the past. So in 2017, I talked to, in the National Association of Water Companies, so the water utilities, why they need to use drones to make assessments on their systems, right? In 2016, I joined a team at ORNL that were studying climate change. And how we were doing that, we developed this sensor that can shoot a laser beam across a room and can measure the amount of methane or CO2 in the field at a particular time. And then make a reconstruction using computed tomography, such like a weather map, that will tell you where a plume of methane or a plume of CO2 is located in the field and what's the concentration. And in 2013, I was interviewed by CNN by the same, that we explaining ORNL technologies that could be used to detect hazardous materials in a setting like the Boston bombing. So that was a very cool experience. And what do we do at ORNL? We combine technologies. So right there you see there is some drones, as I mentioned to you. We did a little bit of a talk on these technologies and how can they be applied to make assessment in the field for a water utility, for example. And we take, so drones, for example, is a technology that it comes with a camera, right? You can fly it up there, you can take pictures of a field, of yourself, your friends. But in ORNL, we combine new technologies, new sensing techniques that can enhance the capability of this commercially available technology. So my contributions in science is to secure our national energy infrastructure, and we do that utilizing drones, like I mentioned, enhanced by sensors that we develop in the lab. And in the slide, you can see a picture, a thermal image, and a visible image of distribution lines. And we make assessment of these systems and see, oh, is it getting hot and why? And we stream the data back to a control center. And this allows the dispatcher and the field crew to have the same information so they can make decisions faster, and they can make a restoration process and fix the problem in a more effective way. And another project I work on now is cyber physical technologies. And does anyone knows what malware is? So malware, okay. What do you think malware is?
It's like a virus or something like that. Something that malware is something like it's like a virus.
Right. It's a piece of software that will do damage to your computer. So imagine if there's a piece of software that will be damaging the computers of a control center of an energy delivery company. That will be catastrophic, right? There will be blackouts, and then hospitals won't be powered, people likely die. So it's super important to study these problems and to develop new technologies and to coordinate agencies and to develop rapid technologies to address these issues when it comes to view. So some of these applications, as you can guess and you can imagine, can be in restoration efforts. Puerto Rico unfortunately suffered the impact of a Category 4 hurricane that caused billions of dollars in damage. Thousands of people have died, and during its almost 8 months, and then still 25,000 customers remain in the dark, remain without power. So what can the national laboratories or scientists can do to help when these systems arrive, right? So there's probably we're gonna be hit by another hurricane, either in the mainland or in Puerto Rico. Hawaii right now is struggling with this erupting volcano, right? And this damages the infrastructure. So some of the technologies that we're developing in the lab, and I work as a team with a bunch of other people to develop this new system that will help first responders, or that will help federal agencies like FEMA to do their job in a more effective way, if you want to call it that way. They have protocols, they have their own technology, they have their own systems that they work with. But we want to enhance that. We want to give them more tools that can allow them to have more information, more data about what's the problem, what is damaged, what resources are available, so they can actually make quicker decisions and things can go back to normal faster, right? So another thing is very, very important is volunteer work. I've participated in many different activities. So you see there, it's Ciencia Puerto Rico. It's a nonprofit organization that delivers STEM resources to schools there, right? So there I was participating of a workshop where there were hundreds of girls interested in speaking with a scientist, just like you guys. And then also I worked at the Hispanic Center of East Tennessee as a math tutor, helping people to get their high school diploma. And what success looks like, I like this picture. I like the Iceberg Illusion, because what people see is the top, right? What you post on Facebook, what you post on Instagram, what you snapshot, right? Like if you take a really hard test and you study for months or weeks, and you did a really good job, you got an A, and you snap a picture with your smiley face, right? That's what people saw, your success. But they didn't see all the struggle, right? Like how many exercises did you do before that? How many times you fail? Your persistence, your determination. Those are things that people don't see, right? But I want you to take this picture and think about it when you are trying to decide what to do and how to do it. And it's not always easy. It's not always a straightforward path, right? So some of the lessons learned that I've learned over the years, and some of my recommendations for you guys, is it doesn't matter the field that you're gonna end up working on, but always find a mentor. And this is not necessarily your supervisor when you get there, right? Or it's someone that will listen to you and will tailor their advice to what your hopes are and what your career interests are. Network, join memberships, do volunteer work. Try to meet a lot of people. You never know who's going to be available to give you your next opportunity. Be flexible, right? My education or my career has never been one straight line, okay? I wanted to study chemistry. I wanted to work at L'Oreal. Well, I didn't get that. I studied chemistry, but I had to jump into French first and then do chemistry, okay? I don't do cosmetics. I could do it if I wanted to, but I have found a new passion in energy delivery systems where I can see the actual impact that the science that we do at ORNL and these technologies have in humanity. And that is very, very rewarding. Don't take no for an answer, ever. If someone says, no, you cannot do that, you're gonna ask them why. And they should provide you constructive feedback. If they don't have constructive criticism for you and tell you you cannot do that because you're not prepared, because A, B, and C, move on to the next person and ask them why. Okay, so that's very important to remember. Always look at the next opportunity, right? Always look at what else can you do. And if what else in terms of the job field, for example, is like what other things I'm interested in, and then look at those. And find your support system. And that could be hobbies, that could be family, that could be friends. In my case, my family, they don't understand what I do. They're like, oh yeah, she's a scientist, she worked with lasers, now she works in cybersecurity, now she works on this, now she works on that. They're like, she's all over the place. And probably that's true. But that comes with the flexibility too. You need to be flexible, learn new things, and always find whatever is interested to you. So your family, you might not get feedback from a specific person that you want to, but that doesn't mean that they don't care. So take them as your support system and build that very, very strong. That's very, very important. So with that said, I will be taking any questions if I have time yet.
Feel free to come on down if anyone has any questions. We'll do one at a time if you want to line up again at the microphone. I know while we're waiting, I'll go ahead and ask a question for you. You were talking a lot about these different energy grids. I saw a lot of power lines in your images. Do you guys do much work with renewable energy resources, solar, wind? What kind of work are you guys doing with that?
So my work is on sensor development. So some of the sensing needs and techniques would be for renewables for solar panel array. You would want to know how much light you're getting to forecast your generation, right? So we work on the type of system and then put it in key strategic places around a substation, for example, to then feed that data into the controls, the utility control system.
I've got a question. What do you think the future of neighborhood grids are? Are small grids that will just service small areas or small neighborhoods that will have their own particular power source?
So there are different requirements for that, right, that we're looking at. For example, and I use this example on Puerto Rico. Yesterday, and I encourage every one of you to listen to this because it's policy changing, and that's something that science do. There was a hearing at the Senate of Energy and Natural Resources Committee where they were looking at, well, what of distributed generation, these tiny microgrids per community, would look like, and what's the regulation and how you will implement it. So some of the key aspects of it is what's the customer base, right? What's the impact on the overall central system? And then in hurricane-prone places like Puerto Rico, it's like, then this community grid is going to help with the resiliency of the system. And if all those criteria are met, then it will make sense to build one. But it's still a debate whether it depends on the area, I guess.
Great, thank you.
What inspired your industry to start working with drones?
What inspired my industry to? Can you repeat the question, please, for me?
What inspired your industry to start working with drones?
With drones? So drones offer an amazing capability to send a sensor to some remote location, right? So then you don't have maybe a location where you cannot drive, right? Maybe it's overseas, and then you want to go see something. So getting, for example, in the pole transformer, you have to get someone up there, right? Someone has to get in the bucket truck and go up there and then do the assessment. So if you have a drone and the operator have a drone that can just go up there, then that it cuts off all the liability issues where what happens if that worker, something fails, right? Then that's a worker that could be in danger. So then this technology helps with make GIS work more secure and also to have an eye on the sky.
And also, what would happen if one of your drones were to have a malfunction or to fail?
Well, I think it fails. It doesn't. There's no much more into it. It's just, these technologies fail sometimes, and then we will try to make it as cost effective as possible, so cheap. Then if one of them fail, then it would be very fast to just replace it.
Have you ever found anybody you didn't know was there, saved any pets you didn't know was there in a building?
To save the pets, you mean?
No, to save people you didn't know was in that location.
Oh, to save people. So
Yeah.
some of the, for example, some of the drone technologies are being used to rescue to see if there's people trapped, like if there's a flooding area.
Yeah.
Where people have to go to upper levels, and then so they are being used as a surveillance device.
Thank you.
Are there any major obstacles that you faced as you were trying to find the right job that you wanted?
Many obstacles, and I think that's part of it, and your determination play a key role. So, for example, there is lots of people that say, no, you cannot do that. That was the main obstacle. And so finding who will going to give you the opportunity, and be very persistent, keep asking for opportunity. If you believe that this is what you're supposed to be doing, you'll get there.
Thank you.
Yeah.
What kind of education did you have in France?
At first? Mm-hmm. So I have, you mean university education?
Yeah.
Okay, so I got a chemistry degree, master and bachelor degrees in chemistry. And then now I completed a PhD in energy science and engineering.
Oh, okay. Back when you lived in Puerto Rico, did you have a lot of experience to do chemistry?
No, I only went to school there. I never got a job, and I got to work there. Yeah, I just finished school and then moved to Tennessee.
Do the drones use infrared rays or something?
They could be, yeah, could be used for that.
What inspired you to work with chemicals?
Well, who does not want to play with chemicals, right? That's the question. I like mixing things and see if they were going to explode, they were going to get hot, they were going to get cold, it's something that I liked. I don't get to do it anymore, but I thought always it was so interesting to just mix two different things and see what happens. It's just a curiosity of mine. Do you want to study chemistry? Yeah, it's really awesome. Yeah.
Okay, so this one says, how do you put sensors on a drone?
So, okay, let's go back on this one, for example. So the sensors needs to be very, very tiny, right? And very lightweight, because the drones are only capable of holding X amount of pounds, depending on the system you're using. There are military drones that are capable of carrying hundreds of pounds, and those are $1 million systems. But the ones that we use are cheap, are $200, $300, $400. So they have to meet certain criteria, and that is they cannot be heavy, and they need to be able to assist and collect data really fast. So the transceiver receiver also needs to be a place on that. So it's a whole it's a multiple components of electronics, including the sensors and other components.
Okay, the next question is, do you get to fly a drone?
I don't, because you need a license to do that, and you need to be certified, and I have not been certified. So I am tasked with developing the sensor, make sure it gets into the drone as a package. And like here in the other picture, for example, that drone that you see there, looking at a transformer, the red box is full of the thermal imager, the visible imager, and chemical sensors. And then those are the types of ones that we put together. And then someone else can go and have some fun, not me. Yeah.
Do you just help our area or other areas?
We at the lab is a multidisciplinary effort, so I work in many different projects that include areas on electrical engineering, nanomaterials, 3D printing, and those are just some examples.
Okay, last one. So you said everyone needs a mentor. So who is yours?
My mentor, I was very fortunate to bump into him at a project meeting. And his name is Peter Fury. He was my advisor at my PhD. And he is absolutely crazy. But he's a brilliant man. He knows lots and lots of people. He has different experiences working in different industries. And he has really helped me to navigate what is the career field, and then also be very, very supportive in other activities I might want to pursue, like entrepreneurship, for example. So we are a great team. And there's other people, like program managers from ORNL and other scientists that also over the years have served as mentors too. All right. Thank you so much. Thank you, everybody. Oh, you're welcome.